So how can a survey of just 1,000 people claim to know what an entire country is thinking? I mean, it seems impossible, right? But it's not magic. It's actually the powerful science of statistical sampling, and we're about to break down exactly how it works.
I think we've all been there. You see a headline about what the public wants, and your first thought is, well, hold on, they definitely didn't ask me. And you know what? That's a totally fair question. So today, we're going to pull back the curtain and see the science that lets researchers get a surprisingly accurate picture of the whole just by looking at a tiny part.
So let's start with the obvious question. If we want to know what everyone thinks, why not just, ask everyone? It sounds so simple, but in reality, that approach introduces a whole host of challenges that sampling is specifically designed to solve.
And this brings us to two really different approaches. On one hand, you have a census. The goal there is a complete count of every single person. It's comprehensive, for sure, but it is incredibly difficult and wildly expensive. Sampling, on the other hand, is all about being clever. It's the smart, efficient shortcut of asking a select few to understand the many.
So why would we take this shortcut? Well, the benefits are huge. It's way cheaper and much, much faster, obviously, but focusing on a smaller group also means you can ask more in-depth questions. And here's the part that sounds kind of crazy. A well-designed sample can actually be more accurate than trying to ask everyone. And that's because you can pour your resources into high-quality training and data collection, which reduces the kind of human errors that can plague those massive, massive surveys.
Now, to really get this, we need to be crystal clear on two fundamental ideas. These are the absolute bedrock of all sampling. So let's break down the difference between a population and a sample.
First up, the population. In statistics, this doesn't just mean the number of people in a country. It's the entire group you are interested in knowing something about. It could be all university students in California, all the light bulbs produced by a factory last month, or every single star in a galaxy. It's the who or what you ultimately want to be able to talk about.
And this is its crucial partner, the sample. Think of it this way. If the population is the entire pot of soup you just cooked, the sample is the one spoonful you taste to check the seasoning. It's that small, manageable slice of the population that you actually study and collect data from. And the key word here, which we're going to keep coming back to, is representative.
This definition really ties it all together beautifully. Sampling is the process of picking that spoonful. And the goal isn't just to describe the spoonful itself, right? The goal is to make an inference about the entire pot of soup. But what does making an inference actually mean?
Okay, inference. This is the crucial step. This is where the real power of sampling comes from. It's the logical leap of drawing a conclusion about the whole population based only on the evidence you got from your little sample. It's a really educated guess, a projection from the part to the whole. And doing this correctly is what separates good, reliable research from just noise.
Okay, so we get it. We need a representative sample to make a good inference. But how do we actually get one? This is where we need to look at the different methods researchers have in their toolkit.
Broadly speaking, you can think of all sampling techniques as belonging to two big families. On one side, you have random, or probability sampling. This is really the gold standard. The core idea is the chance, and only chance, does the picking, which removes human bias. This is what lets you generalize your findings to the whole group. Then you have non-random sampling. Here, selection is based on convenience or judgment. It can be useful sometimes, but it comes with a really high risk of bias.
Let's start with the most basic, most famous type of random sampling. The name really says it all. Simple random sampling.
The process is just as straightforward as it sounds. First, you need a complete list of everyone in your population. Then, you use a purely random method. I'm talking like drawing names out of a hat or using a computer to generate random numbers to make your selection. And what makes this the gold standard is that every single individual has the exact same equal chance of being picked. It is the fairest method possible.
But what if you want to make sure your sample isn't just random, but also perfectly reflects the diversity of the population? Well, for that, we have a more advanced tool.
This is called stratified random sampling, and it's a super powerful way to guarantee representation. So imagine you're surveying a high school. Instead of just drawing names from all the students randomly, you first divide them into distinct groups, or strata. So freshmen, sophomores, juniors, and seniors. Then you take a simple random sample from within each of those groups. This makes sure your final sample perfectly reflects the makeup of the entire school.
Now, there are a ton of other clever methods too. With systematic sampling, you might just pick every 10th person off a list. With cluster sampling, you might randomly pick a few city blocks and then survey everyone who lives there. And sometimes non-random methods are necessary, like convenience sampling, literally just asking people who are nearby, or snowball sampling, where you ask one person to refer you to another. That one's great for reaching really specific, hard-to-find communities.
Choosing the right method is absolutely critical, because even with the best intentions in the world, things can go wrong. A good researcher always has to be aware of the potential pitfalls and the different kinds of errors that can sneak into a study.
There are really two main types of error to think about. First, there's sampling error. You can think of this as the natural error. It's pretty much unavoidable. Just by pure chance, one sample of 1,000 people is going to be slightly different from another. We can measure it and we can minimize it with a larger sample, but it's always going to be there. Then you have non-sampling error. This is different. This is the mistake error. It comes from human blunders and poor design, and with enough care, it is preventable.
And these mistakes can creep in just about anywhere. A confusing, poorly worded question can cause measurement error. A simple typo when you're entering the data leads to a processing error. A respondent not answering truthfully, well, that's a response error. Heck, even the interviewer can unintentionally influence the results. What this all means is that a perfect sampling plan can be totally undermined by just plain sloppy execution.
And this brings us to the million-dollar question every single researcher has to face. We know we need a sample, but just how big does it need to be?
Seriously, how many people do you need to talk to for that spoonful of soup to reliably tell you what the whole pot tastes like? Is it 100, 1,000, 10,000? The answer, as you probably guessed by now, is it depends.
Okay, whoa, don't worry, I promise there will not be a math quiz. This is the kind of formula researchers use, but what really matters isn't the calculation itself. What's important is to understand the ideas that go into it. Deciding on a sample size isn't about picking a random number, it's about making a series of very deliberate trade-offs.
And this is that balancing act. You have to decide on your acceptable margin of error. Are you okay with your results being off by plus or minus 5%, or does it need to be 1%? You also have to set your confidence level. How sure do you need to be? 95%? 99%? And here's a mind-bending little secret of statistics. Once your population gets big enough, its total size barely even matters. A carefully chosen sample of 1,000 people can be just as accurate for a city of 1 million as it is for a country of 300 million. It is all about the quality of the sample, not how big it is compared to the whole.
So there you have it. We've gone from that gut feeling of, they didn't ask me, all the way to understanding the science behind the survey. We've looked at why we sample, how it's done, and what can go wrong. The key takeaway here is that you're now equipped to be a much more critical consumer of information. So the next time you see a poll or a study, I'll just leave you with this thought. What's the first question you're going to ask about how they got their numbers?